Okay, I think we can get started now. As you can see from the first slide on the screen, the session is being recorded, so you might want to keep that in mind for some of the things we'll be doing. So the title of this presentation is Center for Ethics in Science and Technology. I'm the director for that center. It's housed at UC San Diego. And I'm going to tell you a little bit about what the center does, where it came from, and opportunities for you to get engaged with the center while at UC San Diego. The center's goal overall, as noted on this slide, is that we want to promote science in the public interest through an informed and engaged community. So during the presentation and after, there's an option for you to ask questions, a Q&A feature that you'll find at the bottom of your screen. We ask you to not share personal information in doing so. You can submit your questions anonymously, then we'll address as many as we can, either by direct answer in the Q&A to you individually, or some of those I will address publicly for everyone. So I'm telling you about this ethics center. So where did it come from? And that story is a very personal story that begins with my background as a student. I went to UC San Diego as an undergraduate student many years ago. You see a picture on the left of the Revelle College campus back then, which is the school I went to. The provost at that time was a guy named Paul Saltman. Paul gave an orientation talk that I think had a bigger impact on me than I knew for many years. What I remember is that he started talking about the importance of the many different disciplines that one sees in academia. The sciences, the biological sciences, physical sciences, social sciences, but also the arts and humanities and engineering. And what he was trying to get across was that every one of these disciplines is much less if you look at it by itself. What you want to do is you want to connect them. You want to be able to see those connections and recognize how to be an artist, you need to understand some engineering. To be a good scientist, you need to be creative and think outside the box and do things that are unusual. So to be a complete and effective scientist, you want to cut across those boundaries. So I had that idea in my mind, and then as I pursued my career after I finished at UCSD, and for many years, I began pursuing advanced studies as a graduate student and as a postdoctoral researcher, working in many areas of science and engineering, electrical engineering, neuropharmacology, neurophysiology, neuropathology. And then in the 1990s, I got interested for convoluted, complex reasons in ethics in science. And so I became the founding director of UC San Diego's research ethics program by 1997. The idea here was in some ways going back to what I learned as an undergraduate, the need for a full picture. So a full picture of being a good scientist includes focusing on the ethical dimensions of what we do as a scientist. So the program beginning in 1997 was really focused on UCSD researchers, helping them to think about how one conducts their research, how they interact with other researchers. So it was very focused on the researchers themselves, typically graduate students, maybe postdoctoral researchers, sometimes faculty and sometimes undergraduates. But then in the 2000s, early 2000s, the man you see on the lower left, Pete Ellsworth, president of the Legler-Benbow Foundation, got very interested in ethics in science. And the reason he was interested in this was because his foundation had been funding some very controversial areas of research. They were providing the grant money so people could do work. Here's two examples of some of this controversial research. One was studies at a local institute where they were using human embryonic stem cells. And they were placing those stem cells in vitro, that means in culture, outside of the animal. They were taking the animal's embryo, an embryo from that animal, and then placing the human embryonic stem cells in the mouse embryo, and then implanting that embryo back in the mouse so it could continue to grow. A few weeks later, a baby mouse would be born. But the question that somebody who does not know science might have is, will it be a little baby human because it's got human cells in it? And the answer to that, by the way, is no. Only some cells in that mouse's body will be human cells. But Pete Ellsworth was thinking, who's talking about this with the public? Another project going on around that same time at the Neurosciences Institute. They were interested in what they called robot-like devices. You see two of them in this picture, one on the left with the blue and red cones on top of it, and the one on the right with the yellow and purple. And these robot-like devices have the ability to move around, and they have the ability to learn. They aren't programmed to play soccer, which you see here, a soccer game going on. They are programmed to learn how to do better and better, to see what works and what doesn't work. And one of my colleagues said it best. So those robots aren't very good. They were learning to play soccer. And even he or I could beat those robots, robotic-like devices. But those robotic-like devices will keep getting better and better. And we as human beings probably won't. So questions come up with this, and Pete Ellsworth was looking for somebody to help engage the public in talking about those questions. Questions like, what should be done? Should we even be doing this research, like the research with the human embryonic stem cells? Questions like, how should it be done? If you're doing this research, are there things about the way you do the research that could be problematic? Maybe you're doing something involving human subjects that might be risky to them. And finally, when you learn something, what are you going to do with it? How will those results be applied? How will that technology be made available? So out of all of this, we ended up forming the Center for Ethics in Science and Technology. So this center, founded in 2004, was led by two professors, one from UC San Diego, that was me, the other was Larry Hinman, professor of philosophy at the University of San Diego. The center, since its earliest days, has been administratively housed at UC San Diego and is directed now by one of the two founding professors. Larry Hinman has since retired. So coming back to the mission of this ethics center that I'm telling you about, we want to promote science in the public interest through an informed and engaged community. That means we want to help the science move forward as well as possible, but we recognize that if the public isn't involved in conversations about what's going on, the scientists may get ahead of the public and do things that will not be well received and could be problematic. So in short, our goal is to build a community that has a better understanding of science and technology and is able to participate in thoughtful discussion about the ethical challenges and their solutions. So this isn't just left to the scientists, it's recognizing we should engage with the public. So I've talked in fairly general terms now. Let me be a little bit more specific about the kinds of programs we've engaged in. You see in this, this slide some of our programs in the past couple of years. What is in the air we breathe, looking at the kinds of materials and things that we release into the atmosphere. Building better batteries, using nanoengineering to build and improve the batteries that we have and for storing energy. Engineering selfish genes means being able to get in and genetically modify the genes in a mouse so that those genes will be expressed not just in that one mouse, but in its offspring. So every generation after that will have those genes. The fourth one is, how do websites personalize recommendations for me? Some of you may have noticed, and not all of you may know, that when you go onto Google, you go onto Amazon, you go onto things on the web, they're usually collecting information about you. As a result of that, they might then personalize a recommendation that comes back to you. What about shaping our dynamic microbiomes? So for our lifelong health, we might need to know more about these microorganisms that exist in our bodies. So we had some interesting conversations about what's being learned about those and how we might use that to improve health. Ethical boundaries of research with human embryos harkens back to that initial project I told you about before. Reconstructing the brain in the lab to revolutionize neuroscience. I'm going to come back to that one. We did a program on the neuroethics of advertising. What about looking into people's brains to find out how best to market things to them and convince them to buy something? And finally, cybersecurity research. There is incredible work being done at UCSD and other places in the world to try and understand how to make our web presence more secure. And even as we try and make it more secure, there are bad actors who are trying to find ways to break that security. But let me delve a little bit more deeply into this one topic, which is reconstructing brains in the lab. So one of the professors at UCSD is Professor Alison Moatri, who gave a presentation for the Ethics Center some time ago. And Alison is interested in using human stem cells to understand the brain. Excuse me. So let me start this presentation, and you can hear a little bit about Alison's work, and I will be perhaps asking you some questions along the way. Here we go.
I can't stress enough how important it is, this kind of conversation, especially when it's a cutting-edge technology that not many of us have heard or are familiarized with that. And sometimes, especially when stem cells are involved, this might sound futuristic, but it's actually happening right here, right there. And I think that's why I appreciate the opportunity to share what's the work that's been cooking in my lab at UCSD. So I am a geneticist by formation, got a PhD in genetics, and I'm also a neuroscientist, and I've been working on the pediatrics department at UCSD. I'm also the director of the stem cell program at UCSD, and I hope you can appreciate how those two things will intersect during my talk. All the time when I ask my friends or the audience what is a model, I get different perspective, different answers. I'm coming from Brazil, and when I ask my colleagues what is a model, they often relate it to this type of model, right? And to be honest, they are not wrong. This is a model. The same way that this is a model of a train or this is a model of a flying machine. And the point is, models are non-perfect or simplified versions of the reality. And all of those are, in a way, simplified versions of the reality. Not all women look like that. Not all airplanes look like that. But we kind of experiment with models, trying to understand what's reality. And the best models are the ones that you can improve in complexity to get closer and closer to the reality. So that's important in stem cell biology. Talking today about this idea of a mini brain in a dish, and I'll start right there saying that this is the name that is catchy for the media. When you talk about a mini brain in a dish, that's immediately what you imagine.
So I'm just going to stop there for one moment, and I'll continue this presentation afterwards. But I'd like you to reflect on a moment of what thoughts are going through your mind now. This is a researcher who is talking about taking human stem cells and changing them into human brain cells and putting them together in a dish. Now, we're going to come back to a little more of specifically what he did with this, but at this point, think about what you imagine that might mean. Is it something that worries you? If it does, why does it worry you? And feel free to put some of your thoughts or questions in the Q&A. I can't see that directly. I'll have to be told about what's in there during the presentation, but we might come back to some of that later. So let me continue now.
Well, yeah, I mean, these guys can grow these brains inside these petri dishes. But that's a horrible name, because that's not it, and I'll show you exactly what it is. But it's a catchy name, and people have been using it, and I mean, so far so good, as long as you understand that this is not the real representation. The way we generate these mini brains in the lab is by using cells that has been reprogrammed from people. So these are skin cells or dental pulp cells that I can take from the subjects of my research. For example, my son, I got cells from his body, and I transformed these cells into pluripotent stem cells. And from these pluripotent stem cells, I can use a recipe with different factors and different nutrients to guide them to become brain cells. And over the time, they self-organize. That's the key thing. In the past, I thought that I would have to teach the cells how to do it, but they can self-organize and start to mature and form different brain regions or different types of brain cells in there. So this is Isabel. She's a postdoc in my lab, and what she's doing is handling a dish. In each well of those, there are these white dots. There's about hundreds of them in each well. So each one of these white dots is one of these brain organoids. So they can take up to ½ centimeter. That's as much as they will grow. That at the molecular level, they resemble the human brain. And I show you that there are structures that also resemble the human brain. So these are pretty good advancements from the neuroscience perspective. So the question is, can this technology be useful? The other thing is to ask, can these brain organoids think? And so we didn't know if this was a possibility. So nobody has ever tried. And it was during one discussion in our lab meeting that we thought, well, I mean, maybe we should try, we should test. So we plated these brain organoids in plates that are similar to this one here on the left. This is unprecedented in tissue culture, in vitro. Nobody could ever reproduce a brain activity that's similar to the human brain. And if we have that much activity, you can measure something like brain waves. Some people might recognize an EEG. You can see all these waves during EEG. And turn out that we can see those waves from these mini brains as well. So finally, we have been looking ways to mature these organoids. The truth is, on that curve that I show you, after 9 months, we see a plateau. And when they reach that plateau, we don't see any more maturation of these organoids. So we ask, can we actually mature even further these organoids, even though they are not vascularized, for example? So that is the concept of a brain, a vat, a brain that's just floating around. Can we stimulate with experience? And perhaps this brain will think that has a body and actually behave as a normal brain. So there are several ways of doing that. The other way is to give a body to these brain organoids. And I've been discussing about a robotic body. And this is one of the projects in the lab that has help from a high school student here in La Jolla. So he was the one who actually built that robot. And what you're going to see here, it is the robot that is walking and is moving their legs based on the brain activity that's coming from these organoids on the top left. And below here is the computer telling the robot what to do. And you see as the organoid peak on activity, it accelerates or speed up its leg. I'm not sure if you can see from here, but there are actually 2 eyes on the organoids. These are sensors. They are sensing if there is an obstacle come close to you. And as they get close to a wall or something, these eyes are telling the robot that I'm getting closer to something. And the idea now is to use as a learning mechanism where we're going to stimulate these organoids using different neurotransmitters, for example, dopamine, to give them some kind of reward so they can stop and walk back. So in the future, we hope to remove the computer from the equation and make the organoid learn by itself how to explore the environment. I can't stress enough how important it is.
There we go. My slides weren't advancing. So, so I hope your imagination was stimulated by that presentation. The science is very exciting, of course, but today we're looking at some of the ethical issues that go with that. And I hope you appreciate that as exciting as this is, there are some tough questions here. The one is right at the beginning. I asked you about the mini brain aspect of this. What does that name make you think of? Does it make you think of a fully functioning human brain sitting in a lab with no body, with no ability to sense the world or have an impact on the world? Or is there a better word? You might consider whether there might be better words for that. A second thing, remember I said one of the questions we have is how should science be done? Interesting question about what does it mean when somebody chooses to include their own family as part of the subjects of the research. As Dr. Mwatri mentioned, he used cells from his own son because he's trying to understand things that affect his son. So what are the pros and cons of us doing that? And third, and perhaps most challenging and challenging to our imaginations, is this idea, do these brain organoids think? And when you first ask that question, it seems simple, but then you start to dig deeper, you realize it's very nuanced. So is it thinking because you can get brain waves from the organism that are similar to what brain waves might look like in a developing human child? And the answer to that is that's not necessarily thinking. It's electrical activity, but it doesn't mean that there is thinking per se, depending on what you mean by thinking. You might mean it has to do with learning. So can something learn by experience? Well, I can create an algorithm on a computer that will learn to do better and better, such as Watson, the IBM computer that learned to play Jeopardy and learned to do better and better. But is Watson really thinking? Is Watson really a living organism? And depending on your perspective, you might answer that yes or no. Those are the conversations that we want to have as we talk about these various topics. So what kinds of questions about the science and technology do we ask? We often have to start with, what is it? What is the technology we're talking about? On the right side is something from human embryonic stem cell research. So in California, you may know that about 15 years ago, the voters of this state decided that they wanted to dedicate $3 billion to human embryonic stem cell research. It was a very controversial initiative. There were people on both sides arguing vociferously both ways, and it passed with a pretty substantial majority. But my sense was that if you talk to somebody who was voting against that initiative and ask them what they were voting against, many people had a picture of human babies were being sacrificed and used to be able to create these cells. And so it was a misunderstanding that they were voting on, because in fact, that wasn't what was being done. At the other end of the spectrum, there were people who thought, oh, when the scientists do this work, they are quickly going to find cures to Alzheimer's disease, Parkinson's disease, diabetes. And that also is simply not true. These are important steps that the scientists wanted to take, but they aren't necessarily answers to the questions right away. So interestingly, one of the biggest problems from an ethical perspective is that people were making decisions without fully understanding what they were talking about. So you start with, what is it? Second is to ask, why is it being done? What might somebody want to do with this? There's a video camera shown in this image. So why do we have video cameras? We put them up theoretically to try and improve security, to try and let us know what might be happening in an environment. But when we do that, what are some of the challenges that go with that, such as a loss of privacy? We can be more secure, but we have to sacrifice our privacy in order to do so. What about, does it even work, whatever the technology is that we're developing? And this one is a really good example of a tough question we may have to face. Regardless of whether you believe climate change is caused by humans, the reality is that there's evidence that our climate is changing, and changing in ways where we might find the planet is warming. too much. We might want to be able to control that climate. Some scientists are studying ways to engineer the planet's climate, to change that climate. You might say, well, that would be great. If they can do that, we can adjust it like the thermostat on your heater at your home. That would be great if we could do that. But this is a new technology that's being developed. How well will it work? What if we can control the climate in one area but not in another? How much, what does it really mean to work in that case? And those are questions that we might not get full answers to until it was applied, and then it might be too late if it's going to be something that is difficult. So the question that we should be talking about is, does the technology work? How might it be used? You can imagine many wonderful uses for a drone. It can be very positive. There was a very unfortunate incident in Texas a few years ago where some of you may have seen this news story, where there was someone who was shooting people, an active shooter, and somebody in the local security forces came up with the idea that it was too dangerous to try and approach this individual directly, but what they could do is they could send a drone to a room very near where this person was, and next to the wall where this person was, and the drone carried explosives so that it could explode and then incapacitate that individual on the other side of the wall. So you might say, that's good, we stopped the person who was shooting others, but you might also say, how could other people use this for not as good purposes? You might also say, what if it had gone wrong? What are the things that might have gone wrong when they did this? So how might the technology be used? What is possible? What is impossible? We have a company in San Diego called No Lie MRI. MRI, or magnetic resonance imaging, is the use of a technology to look at the brain, but look at it when it's functioning, when it's doing something, to see which areas of the brain are active and which areas are inactive. So they have taken that simple observation about being able to see the brain in different states and done experiments to see if they can tell when somebody is lying, to tell when they're being deceptive. They believe they have figured this out well enough that they now have a product that they sell. So if you want to go and prove to somebody else that you aren't lying, you can pay them to have you go through their procedure, and they will ask you the question that is at issue, and you will give your answer, and they will then say whether you're lying or not. So does that really work? Well, many people who look at this kind of technology would say, how can you design an experiment appropriately to test that? Because if somebody is being tested for that, then they don't have the same stake in the outcome that a real person would. And what happens if, for example, the person believes something is the truth when it's not the truth? What happens if somebody has a psychopathology? Maybe they, a pathological liar. Maybe they would be very good at, it wouldn't look like lying. So is it possible or is it impossible? At least at this point, I think the jury is still out on whether that works. Finally, what could go wrong with the technology? Increasingly, we're seeing cars on the road that are able to be semi-autonomous, I think we'd say. They're supposed to have a driver still present in the car, but the car can operate considerably well without the driver interceding at all. Unfortunately, in some cases, some horrible things have gone wrong, where the car has misinterpreted the visual information it's receiving and resulted in an accident, even killing the driver of the car. So we need to be attentive to thinking about what might go wrong with these new technologies as we develop them. All right, so I'm going to start wrapping up here. And as I do start to wrap up, I want you to be thinking about questions about the Ethics Center and what we do and the projects I mentioned. Feel free to be sending those questions in now. But let me tell you a little bit more about the center and ways that you might get involved if you're interested. The audience for this center is diverse. We're interested in voters, the people in the community who vote. Many of them are non-scientists. We're interested in the next generation of community leaders, the youth of our community. We're interested in teachers, those who educate that next generation. We want to reach out to journalists as well. Those are the people who are responsible for making these new developments in science and technology accessible to that community. And finally, policymakers, those who have an impact on legislation and regulation. It's the kinds of things we do can have a profound impact on the society we live in. So in order to do that, our typical programs that I've been talking about are typically at, and I've emphasized typically because things are a little bit different right now because of the pandemic, but we normally have the programs at San Diego's Science Museum, which is the Reuben H. Fleet Science Center. To date, we've had over 150 programs at the Fleet Science Center. And these aren't just lectures. We have the speaker speak for 20, 25 minutes, and then the remainder of the time is for engaging the audience so they can identify and propose solutions to ethical challenges to scientific advancement. Over 70 of those programs have been recorded by UCSD TV, and those are widely watched with an average of over 100,000 online views each. So, in the hope that you'll be at UCSD, do you want to join us? You can certainly, anytime, right now, whether you come to UCSD or not, sign up to attend or watch upcoming programs. And this is one of the good things about the circumstances of the pandemic, which is that because our programs are now online, somebody anywhere in the world can watch them. They are typically the first Wednesday of the month, 5:30 to 7 p.m. San Diego time. And just go to this URL, ethicscenter.net. You can see what's coming up next. And actually, coincidentally, this next program, the day after the coming election, will be talking about something very relevant to the coming election. We have a researcher who is using effectively artificial intelligence to try and look at a news story and determine whether it is being objective or being sensationalist. And we're going to be talking about that the very day after the election, which is a really appropriate time. So hopefully you can join us for that. But also, if you come to UCSD, if you're here, you can volunteer to be a student representative working with the Ethics Center. We reach out periodically to undergraduate students and graduate students and invite them to help us communicate with other members of their communities, their peers, to come up with ideas, and depending on their enthusiasm and interest, to actually get involved in creating content and ideas and programs and activities for the Ethics Center. So there will be as many opportunities as people who are interested in joining us to be part of that.